All right, let's journey into the vast, silent emptiness of space. It might look peaceful, but up there, an invisible war is being fought every single second. Today, we're going to look at the mind-bending science that JAXA, Japan's Aerospace Exploration Agency, is using to protect astronauts and satellites from a threat you literally cannot see coming.
Get this. This isn't from a sci-fi movie. It's straight from JAXA's research. A tiny piece of metal, no bigger than a marble, can hit with the force of a hand grenade. That's the terrifying reality of space. So the real question is, how in the world do you build a shield against something so small, but so incredibly powerful?
Well, the secret ingredient here is speed, an almost unbelievable 28,000 kilometers per hour. That is how fast these invisible bullets are moving. We're talking more than 10 times faster than a bullet from a sniper rifle, fast enough to zip around the entire planet in just 90 minutes. And at that kind of velocity, the normal rules of physics they get rewritten in the most violent way imaginable.
So let's really break down what that incredible speed actually means. What happens when an object hits you at what scientists call hypervelocity? The answer is, well, it's both fascinating and, honestly, a little horrifying.
Yeah, it's a great question, right? Hypervelocity just sounds extreme, but how extreme are we actually talking about here? Let's try to put it into a perspective that makes sense back here on solid ground.
Okay, look at this. A high-speed train, it causes a lot of damage. A sniper bullet? It'll pierce right through metal. But now look at that last row. At orbital speeds, solid things don't just break or shatter, they instantly vaporize. The energy is so immense that the object turns into an expanding cloud of superheated plasma, which can actually be even more destructive than the thing that hit it in the first place. And all of that leads to this absolute nightmare scenario. See, just one collision can create thousands of new pieces of debris. Then, each one of those pieces can cause another collision, creating millions more. It's a chain reaction, a cascade that could wrap our planet in a lethal shell of shrapnel, essentially trapping humanity on Earth for centuries.
So, how do you even begin to stop a bullet that turns into a bomb the second it hits something? Well, you build a bigger, faster gun right here on Earth to figure it out. Let's take a look at the incredible piece of engineering JAXA uses to simulate these impacts and design the shields of tomorrow.
Meet JAXA's two-stage light gas gun. This thing is an absolute beast. Here's how it works. First, a regular gunpowder charge fires a heavy piston, not a bullet. That piston then slams into a chamber filled with a light gas, like hydrogen, compressing it to an absolutely insane pressure. Finally, a tiny membrane bursts, and all of that hyper-pressurized gas explodes outwards, launching a tiny projectile at up to 7 kilometers per second. Okay, so building a cannon that can mimic space impacts is one thing. But if you can't see what happens in that tiny fraction of a second when the collision occurs, all that data is useless. So how on earth do you film an event that's literally over before it even begins?
You start with a camera that can do this, 10 million frames, every single second. Just to put that into perspective for you, the phone in your pocket probably shoots at 30, maybe 60 frames per second. It's orders of magnitudes faster. It can freeze moments in time that are almost too small to imagine. But believe it or not, even that isn't enough to get a perfectly clear picture.
The real genius is a technique called shadowgraph. Instead of trying to shine a light on a tiny, super-fast projectile, they do the exact opposite. They shine a super bright light directly into the camera lens. Then, when the projectile flies past, it creates a perfect, razor-sharp black silhouette against that bright background. Motion blur is completely gone. It's just a brilliant physics trick to let them see the unseeable.
So with this incredible super cannon and their ultra-high-speed camera setup, JAXA can finally get down to business designing the armor that protects astronauts and billion-dollar satellites every single day.
And this is the result, the Whipple Shield. It's used right now on the International Space Station, and its design is just brilliantly counterintuitive. It's this elegant two-part defense. Instead of one big, thick wall, you have a thin, sacrificial outer layer placed a short distance away from the main hull. When debris hits that outer layer, its only job is to vaporize the projectile into that plasma cloud we talked about. That cloud then expands and spreads its energy harmlessly over the much larger, much stronger inner wall. It's genius. You defeat a solid bullet by turning it into a gas.
And JAXA is already hard at work on the next generation. They're testing everything from super lightweight carbon fiber and metallic foams to these incredible self-healing materials that literally bleed a resin to automatically plug any holes. This is the exact technology that's going to let us build lighter, safer bases on the Moon and Mars,
using inflatable structures protected by these kinds of advanced fabrics.
But what's truly amazing is that this kind of hyper-focused space research doesn't just stay in space. The knowledge they gain from stopping these invisible bullets is having a profound impact right here on Earth and on our future plans for exploration.
For example, take the upcoming Martian Moon's Exploration Mission, or MMX. JAXA is planning to land a probe on Phobos, one of Mars's moons, but the gravity there is so weak that landing is more like docking. You have to be incredibly gentle. So JAXA's impact tests are absolutely crucial for understanding what the surface is like to make sure the lander can touch down gently without just bouncing right off into space.
And back here on Earth, the physics of these extreme collisions are, believe it or not, surprisingly relevant. The complex computer models they develop for designing satellite shields have found some really practical, down-to-earth uses.
Yeah, the benefits of this research really do extend to all of us. Those models of how metal bends and deforms at high speed, automakers now use them to design safer cars. The physics of how a debris cloud expands, that helps engineers build better barriers to protect against things like landslides. And those incredible ultra-high-speed cameras, they're now being used to study how smart pills release medicine once they're inside the human body.
JAXA's work is just this powerful reminder that sometimes the biggest threats are the ones you can't even see. By figuring out how to stop these invisible bullets, they're not just making space travel safer, they're improving life on Earth in ways we never expected. It really makes you wonder, as we push further and further out into the cosmos and as space gets more crowded, what other unseen challenges are just waiting for us out there in the dark?